This is the experiment, Einstein on the plank. What I like to point out is that in this video, Einstein initially was not moving, and then suddenly he starts to move. For analyzing maximum static friction, we need to find out that exact frame of the video that's right before he starts to move. In other words, it's the last frame when he was not moving. After that, we analyze this frame. Because Einstein is in equilibrium, he's at rest. So we apply Newton's first law. So the Newton's first law here is along the x direction, the sum of all forces equals to 0. Along the y direction, the sum of all forces equals to 0. Then apply the definition of static friction maximum. That's what this frame is. That's the exact point before he starts to move. Then we combine the equations. Static friction coefficient equals to tangent the angle of the plank. If we are able to measure the angle, then we can calculate the friction coefficient. After Einstein starts to move, it's a totally different motion. So here is going from rest, now it's moving at a constant acceleration. Because it's moving, we use the kinetic friction coefficient. Okay, so we select the frame of the video. That's the first one moving. So this is shouldn't be, so this is the previous one, so we advance one frame. To analyze this frame, because it's a one-dimensional motion with a constant acceleration, it has a acceleration A. Newton's laws are different. For x direction, because it starts to accelerate, we apply Newton's second law. So the sum of all forces along the x direction equals to ma. Okay, y direction is not changing because he's not moving along the direction that's perpendicular to the plank. Okay, if we apply the friction's definition, and then on the left and the right are the two parts from the above equations. If we combine this, we can solve for the kinetic friction coefficient.